So I'll try and make this as entertaining as possible. There's quite a bit of info here, kind of on purpose. My goal is to get you thinking about some of the mistakes that I've made, perhaps, some of the lessons I've learned with my team over the last few years with implementing continuous delivery and modern architectures. And when I mean like modern architectures, I really mean microservices and kind of, some people are calling nanoservices, but things like serverless, function as a service. Done a bunch of work with microservices, even before we called it that, bunch of work with serverless, and I've learned, hopefully, a few things I'm going to share, made many mistakes. And one of the reasons I very much enjoy coming along to conference talks is so I can learn the mistakes so you don't have to make them. Yeah, that's my goal today. What we're pretty much being sold at the moment is everything should be better if it's smaller. I've seen a few talks today that have kind of warned about some of these things. There's nearly always complexity in the business problems we're solving, and we're just pushing the complexity around. We don't want accidental complexity, but in the kind of domains we operate in, there is always some level of complexity. And microservices, function as a service, primarily around pushing that functionality, pushing that complexity around. We're kind of pitched that if we package our applications up, carve them up, small modules, discrete, maybe put them in a container and ship them, we're all good. That's the pitch, pretty much, yeah? Many of us in the industry are doing. The snag is, if we're putting a tire fire in a container, what you actually get is literally tire fire in a container, yeah? And I've been there, it's not a good look. Often what we end up doing is firefighting, yeah? And what we tend to call this in our industry is DevOps, yeah? Putting out the fires. I've certainly been there, yeah, I've done this. You know, I've caused my fair share of fires. The high-level takeaways, and it is going to be quite a bit of info, but what I would like you to be thinking about, hopefully at the end of the day, is that we are moving from complicated systems, SOA, all that kind of, monolith, SOA, that kind of thing, to complex systems. And the jump from complicated to complex is a big jump. You get emergent behavior, things like that, yeah? Architecture, for me, is becoming more and more about technical leadership. I take a lot of my cues from people like Simon Brown, Pat Couar, Martin mentioned them already today. I do a lot of architect-type gigs now. I perhaps code less and less, but architecture for me is not just about boxes and arrows. Architecture is about system quality attributes, non-functional requirements, as we call them, which we'll look at today. And for me, in a microservice project, a lot of the role I do is about making sure things work together. Yeah, we're carving all these things up, but still we need to deliver functionality. My role as an architect is often about helping teams knit things together. I am a huge fan, as I'll show on the next slide, of continuous delivery. And for me, it's a kind of catalyst for encoding our requirements. Yeah? We, as engineers, really should take requirements and codify them. Kind of, it works for me, or this feels right, isn't really a valid approach, particularly when the business and the world is changing so fast. We need to be able to react to the changes, but verify we haven't broken anything that is already there. The world is also changing fast, as Simon said this morning. Security threats are popping up everywhere. We need to be able to verify that we're not impacted. I'm sure a few of you heard about Equifax in the US. I do a lot of work in the US. And Equifax had a struts vulnerability. Massive impact. A bunch of my friends in the States have had their credit history shared, and they've been victims of fraud and crazy things. It even impacted a little bit us in the UK as well. So we need to think about these things. These are my takeaways. If you want to go to sleep now and wake up for the beer, these are the 3 things I hope you remember. This is me, at Daniel Bryant on the Twitters, GitHub, LinkedIn, you'll find me there. I have an interesting, career in terms of I was started as an academic, and then I went to consultancy and did a couple of CTO roles. And I'm a big fan of continuous delivery. Along the way, that's something I always, I took my cues from Jez Humble and Dave Farley, the classic book, and wherever I went, I found it was a real catalyst for driving innovation. It's like I think of it as like a kind of oiled factory, oiled machinery, that I put ideas in one end and out pops business value. That's when you get it right, that's what it's like. I am a firm believer of people over technology. Most of the people ring me up and say, can you come and install Kubernetes? And I'm like, yeah, no worries. I get in there, and basically it's dev not talking to ops. And no amount of Kubernetes is going to solve that. Yeah, a lot of the stuff I do these days is organizational change. And I'm reluctantly, to some degree, embracing that. I love Java, I love coding, yeah, but I realize I can add a lot of value sometimes, or many times, hopefully, by actually helping people and the teams at large thinking about the way they're kind of building the software. Enough about me. Anyway, books there you can have a look at as well. But setting the scene, so continuous delivery. I'm sure people generally bumped into continuous delivery. People are pretty familiar. I do this talk many different places. It's all about producing valuable and robust software in short cycles. We are optimizing for feedback and learning. Optimizing for feedback and learning. Those are our key things with continuous delivery. It's not necessarily about rolling things into production automatically. You can do, many companies I work with don't, and that's fine. It's about being able to release at any given moment. We know what's on master, trunk, mainline. We know that is good to go. These days, most markets, whoops, not looking good. We okay there? Most markets are about, we're running around. I'll press on. Oh, there we go. I'll press on. Most markets are about velocity and stability is key to business success. The Spotify are the kind of archetypal ones here. Spotify, a streaming music service, if they can out-innovate and out-compete their competitors, they get more market share. They get more money. Yeah. If I'm building software for a nuclear reactor, probably stability is more important than velocity. Yeah. There's every one of us has got different requirements. We're obviously not all Google. We're not all Netflix. We're not all Amazon. But we can learn a bunch of stuff from them. And for me, continuous delivery, this quote from Steve I think is brilliant, is achieved when stability and speed can satisfy business demand. Discontinuous delivery occurs when the opposite happens. So the key thing here is something I've learned very much as a consultant, made a bunch of mistakes at the beginning of my career, but context is vitally important. Yeah? I often think now, my role is somewhat of a software psychologist. Yeah? A lot of my clients know their problems or can easily find their problems if they ask the right questions. They're not always comfortable questions to ask, but I go in and I try and help them these kind of things. But you've always got to remember your context is key, and speed and stability mean different things to each one of you in this room. I'll go through very quickly standard Java pipeline that I've been using for many years now. Apologies, it's a little bit small, but we're typically coding on our laptops, aren't we, doing some local dev. We push it to GitHub, Bitbucket. We do some CI in Jenkins or Circle CI. I actually love Jenkins. It's a love-hate relationship with Jenkins, but Jenkins has served me well over the years. If it builds, we then push it to a code like Nexus, an artifact repo. We might do some quality checking on the code, that kind of thing. We push it to QA. We do some tests. We push it to staging, do some more tests. And all along QA to staging to prod, we're getting more realistic, more like live. QA, I may be using mocks and stubs. Staging, I may be using service virtualization for third-party services, or sandboxes, PayPal sandbox, Stripe sandbox, and obviously prod is the real thing. Here we go. Many teams I initially start working with think this is pretty much continuous delivery, or at least the blueprint, if you like, for it. A key thing that people sort of forget is it's all about that feedback and that learning, yeah? Did we prove our business hypothesis? Are we getting better from a code point of view, from an architecture point of view, from an ops point of view? Closing the loop is super, super important, yeah? And it's all too easy, I've done it, to kind of forget some of these things. Your service or your application is not done when it's deployed, it's done when it's retired, yeah? These days we've got to keep looking after these things. Many of us are using Docker or the container technologies. It changes things a little bit. Even if you're running serverless, it typically is running in a container. If you're using Lambda, for example, it is a container, an operating system container behind the scenes. And it changes it a little bit by maybe you're using Docker or Rocket on your local machine when you're developing. Maybe you're now storing a Docker image or a Rocket image instead of a Java jar in Nexus. The way you spin up things and you do your testing might change because you're using containers. And most importantly, the fabric in production changes. Ray just did a fantastic talk about Kubernetes and Istio. Now we've kind of got another layer of abstraction with Kubernetes. Kubernetes, maybe a virtualized hardware underneath and so forth. It's kind of turtles all the way down. But we as Java developers need to cultivate mechanical sympathy with the platform we're deploying onto. I did a talk at Java 1 a couple of years ago. You can see online. I made so many mistakes. My first big project with Java and Docker, and I bumped into things like pre-Java 9, Docker is not C group aware. So Docker sees all the resources on the box and tries to grab them. And the control groups and the Docker, for example, the Docker daemon, will not let that container grab all the resources. But the way the JVM spins up, it bases all its things like fork join pool, garbage collection threads. It bases it on what it thinks it's got access to. Because Java back in 1997, when it was created, it was deployed on a machine and it grabbed all the resources. These days with Docker, we cordon off the resources. But now, I think Java 9 made some really good changes, and Java 10 in particular has done a lot of fantastic work that makes Java much more friendly, and the JVM much more friendly with Docker, for example. But we need to think about these things. I digress a little bit. What are our core challenges with modern architecture? And really, it's moving from this to this. Simple as, really, isn't it? And one, it was a monolith or some SOA. Now we've got more things in the mix. And if you're using serverless, multiply that by 10 or 100, because you typically have smaller functions and you need more of them to do more things, do the same things. Sorry. This is fundamentally it. What we want to do is we want to go fast. Yeah, and there's a couple of ways you can do this, a couple of patterns. You can do the kind of coordinate on staging, and then if you agree that version, say you got version 1 in the top pipeline, version 2 of the middle pipeline, 3 of the, or 5, say, of the bottom pipeline, we can agree that if we push it all to a staging environment, run a bunch of tests, and it passes, we can release that as V1 of our app. Be aware that that's a totally interesting pattern, totally valid pattern if you're starting with microservices, because you get some benefits by splitting up the teams and the code base, but it is fundamentally a distributed monolith, because your cadence is based on putting everything into one kind of staging area, doing all your tests, even if they're automated, and then deploying like that. What's that? Oh, just taking a bit of time. There we go. So that's one pattern, the gated application deployment pattern. Can be quite nice. It's good to kind of break up the code bases and so forth. What many of us are after with microservices, though, and serverless, is the independent service deployment. We want to be able to push kind of, things independently. Maybe the top app is something that's changing all the time. The middle app and the bottom app here, they only change once a year. So we don't want to be packaging up all our EJBs and packaging up all these things. We want to be able to have independent release cadence on each of these pipelines. The snag often comes in relation to stability here. Yeah? And sort of in terms of functional stability, one of the biggest ones is if my team says, the bottom team, we're working on some code, we push a change, we change our API, and it actually breaks pipeline 2. Yeah? We completely, by accident, we thought, oh, no one's using this API, no one's reading this field in a message, we'll just change it a little bit, we deploy it, boom, falls over. I do increasingly see my role as an architect at kind of trying to prevent many of these things, because I see this, you've probably seen a similar meme in the past, yeah? And I do often work with teams now where they're like, well, all the tests passed locally on my machine. As soon as I pushed it to production or whatever, it all fell over. And I'm like, oh, and that's my fault for not clearly specifying the contracts and clearly specifying the interactions. It's also about architectural quality, yeah, making sure you're maintaining good quality software. I do frequently seen, unfortunately, teams that have this monolith that's kind of crazy because it's just, battle scarred over years of use, and they break things up to microservices, and within a year, several of those microservices have become monoliths, effectively. Or the code quality is just as bad in those microservices as it is in the monolith. Yeah, we think by breaking things up and it'll all be a new start, but we don't change our habits quite often, which is a dangerous thing. I'll give you some tools to help with that stuff. Performance is a key thing. Martin did a fantastic talk today. I'm not going to cover performance too much in this talk because of time, but I've got some other talks online on YouTube. You can check out where I look more at using Gatling and various things. I know many people actually from the NLJug. I think, I can't remember who it was now, did a fantastic talk at Java 1 a couple of years ago about using Gatling, so you can look them up on YouTube as well. Yeah, NLJug, but I can't remember who it was. And also security, as Simon talked about today. Security, looking for vulnerabilities in your code, your dependencies, the way you package and deploy, this stuff is super valuable, yeah? So next couple of slides are a little bit of an eye chart, as we say, a little bit of an eye test, but they're just to get you thinking about how some of these things have changed. The slides are already on SlideShare, so you can go home, go back to the office and have a look at them. I wanted to set some context to get you thinking a little bit about how the world has changed and how we need to change kind of thinking. So I started my career back in the 90s, pretty much. It was monoliths. I started coding Java 1.2, I think it was. We were doing some SOA stuff as well. I was using some really sort of fun tools, very productive, but it was all deployed as one unit of code, pretty much. Yeah, we were deploying on servers and so forth, on fixed servers. As I moved into 2000s, we started looking at more and more kind of SOA and so forth. SaaS became a thing, software as a service, and then we moved more towards smart pipes. Yeah, and smart pipes and we moved more towards smart pipes in that we often pushed functionality that, like Ray mentioned this just a minute ago, functionality we think we need a cross-cutting concern. Fault tolerance, transport security, transformation of messages, we push that functionality into things like enterprise service buses. I'm sure a few of you have worked on enterprise service buses. They're a fantastic tool, but often the logic, your business logic, gets spread in the ESB as well as your code. And then when you're rolling out code, you have to update your application, but you have to update the ESB, for example, as well. Always a trade-off with these things. Now in the 2010s, it's very much about microservices. We've gone to this dumb pipes thing. So dumb pipes is Martin Fowler's famous quote. We're looking at things like HTTP, Kafka, and so forth. We're putting more responsibility into our services than we previously put into ESBs, for example. We are kind of seeing a resurgence with centralizing some of that with things like service meshes, things like Istio and so forth. But at the moment, sort of 2010s are primarily around decentralizing this kind of control over messages. We're doing polyglots. This is very much where we're at now in terms of as we've moved across the time. We've gone for kind of simple, relatively simple concepts. And I'm bending what's called the Cynefin framework here. So if anyone's familiar with the Cynefin framework, you might recognize it. But we've gone from quite simple kind of systems where I could look at the monolith. I probably couldn't understand all of it, but I could get it all on my IDE. I could start playing around with it. And when I deployed it onto a server, I could look at that server. 2000s, I have to look at the ESB as well as kind of look at a few coarse-grained bits of functionality. That was kind of complicated, yeah. But as we've gone now into 2010s, it's more and more complex. When I look today, it works. When I look tomorrow, it doesn't work. And I don't really know why. Complicated systems, the cause and effect is we can usually figure it out. Simple systems, very simple cause and effect. Complicated, we can usually reason back through. Where complex systems, you think about all these different microservices, different service, different functions as a service. They're coming, they're going, they have different performance characteristics one day compared to the next, just because we're using things like commodity hardware in the cloud. It requires a kind of different mindset. If anyone is familiar with Cynefin, you'll see the chaotic kind of zone. You don't want to go in the chaotic zone. It's kind of dragons be there. But we're kind of calling this, where we are now, is cloud native. We're kind of labeling cloud native. And there is fantastic technologies available in this space, yeah? As a kid growing up, my first computer was an Amstrad CPC 464, kind of similar to the Commodore 64. I was coding in 64K memory, happy times, but I could never even dream of accessing the hardware I can now. Accessing all things like Istio and Kubernetes, all these amazing things. But I think the architecture hasn't often caught up. Yeah, we've got fantastic technologies in this cloud-native domain. I think we're struggling. I'm struggling sometimes with how do I apply all these fantastic technologies to actually deliver business value fast and stable, velocity and stability. And this kind of, again, apologies for the eye charts here. I'll pick out a few things. As we've gone kind of from monolith to SOA to microservices and serverless, the whole kind of all the ways I look at a project have changed. And I'll pull a few things out, yeah, because when we're in a monolith, the organization is implemented and maintained by a single team. It's much easier to test things because we're all kind of crowded around the same code base. The deployment is pretty much, once we get it right, we're good to go. There's not multiple components. Things aren't constantly changing. If we look at the sort of SOA days, yeah, there was more components involved, but the management was centralized. So testing meant you spun up everything together, ran all your tests, good to go, that kind of thing. The way you did security was typically more baked into the frameworks as well, and so forth, into the smart pipes. Moving to microservices, we're trying to deploy things individually, but this means there's an inherent nature of a distributed system. If you're building microservices, you're kind of building a distributed system. And they have whole new rules, as I found out in a project 5 years ago, where everything in the cloud is on the network. Performance characteristics are very different. Things just fail in random ways. Then one service can talk to one, but it can't talk back to the other. Or latency randomly spikes. It's kind of crazy at times. But we're often choreographing the services now. We're breaking our monolith up. What was in-process calls, we're now choreographing the actual functionality between all these services. Testing that is a bit harder. And if you go to kind of things like serverless, often we have to orchestrate things, because choreographing only works at a coarse level. So I'll explain more what those things are later on, but I'm finding when I'm working with serverless kind of code and so forth, I develop my functions here, and I develop like a declarative kind of file that specifies how they work together. And I'll show some examples of that in a minute. Testing that is very different kind of than I've been used to in the past. A lot of what I'm going to focus on now is about sort of testing microservice integration. One of the hardest things I think teams bump into when they suddenly start experiencing pain. Actually, let me start again, sorry. One of the hardest things people bump into with microservices is when they start testing. And it's usually fine. You got 1 or 2 microservices, not too bad. You get 5, you get 10 microservices, suddenly testing the integration becomes a lot more painful. I'll fall back to the classic. Hopefully, a few of you bumped into things like the test pyramid. Yeah, a bit like Maslow's hierarchy of need. We should have more unit tests on the bottom than we should integration. But there's value in all these things. There is clear value in manual exploratory testing. Trust me. I see a bit of a pushback in QA in a few of the jobs I work in, but a good QA, they're worth their weight in gold. The way they think is often different, fantastic insight into how to break systems. So all these things in the testing pyramid are essential, but we should probably skew towards more automation for unit testing, things in the bottom. The testing quadrants from Janet and Lisa's book, fantastic book, Agile Testing, and it talks about we need to think, are we trying to do a technology-facing or a business-facing test? Are we supporting the team, or are we critiquing the product? These are really nice models to help us think about how we do testing, regardless of technology. These are really nice things, and I'll draw on them a bit in a moment. What I see quite a few teams struggling with microservices is they tend to think inside out. They build a user service. They build a checkout service. They build an algorithm kind of service. Whereas when I've had the most success, I've built outside in. I do the whole three amigos thing. I sit down, I'm a developer, I sit down with a QA person, I sit down with a business stakeholder. We chat around the business problem, and that in itself is super valuable. Honestly, as a consultant, getting people in the same room sometimes is the most value I can add. Yeah, people in organizations have sometimes never even spoke to their colleagues. It's bizarre sometimes, yeah. But as a consultant, the more money you charge, the more important you become, which is kind of bizarre, but good as well. So you get these people in the room. You can also codify these things using techniques like behavior-driven design. Yeah, it's a bonus. If you can, I have had some companies where there was a lot of pushback initially, but once we got the business people kind of doing Gherkin and writing Cucumber, it was just fantastic. The speed, the collaboration, the QA, the developers, the business, we're all using the same language. It was awesome. Trust me, it was awesome. I've had a lot of success with Serenity. It used to be called Thucydides, but no one could pronounce the name, so they changed it to Serenity. It's by a gent named John Smart, awesome gent. Many great books over the years I've read that he's written. Java framework, you can use JBehave, you can use JUnit. It's a great way to get people thinking, what business functionality do I need? And then you develop outside in. You want to do that at the business level. So if you're building an e-commerce site, you think, I need to browse for products. I need to look at the product's details, I need to add the product to my checkout, and I need to check out, as in actually buy the product. And then as you break up the domain, and I'm not going to cover this kind of stuff yet in this talk, but maybe you're using domain-driven design, maybe you're using something else. But as you break up this kind of business idea into different services, you want to do the outside in, if you can, for each service. Yeah, so one classic example I worked on with the team was we were building a checkout service. So it was e-commerce, it was checkout. A really good thing for us was when we started, we came up with the business functionality. It was myself, a few developers, a few architects, QA, business. We came up with the business functionality that service should provide. Not the technical REST API, anything like that, the business functionality that service should provide. Not only did we then kind of go outside in, we used Serenity, we captured in BDD all the, the refunds, the pre-auth, all these business context things, but as the developers, as we filled in all the blanks here, we were using the same language as the business, and we spotted a bunch of problems. It was just really nice. We kind of started right at the whole e-commerce thing, but as we got further and further down, we were still doing the outside-in development. And a key thing was when we came up with scenarios where we couldn't define the business function, it was often a sign that we'd made the services too small. Yeah? And there's some kind of functionality you want to code, maybe like an authentication service. There isn't really business value with an auth service. So there's a few exceptions to the rule. But we definitely found when we were coding a microservice, if we couldn't sit down with the business and explain and work together to understand what that service did and codify it in Serenity, we probably had made the service too small or it was too technical. Yeah? So that was a great kind of anti-pattern for us to spot. But it's a really nice framework. One thing we kind of figured was that the microservice, the test pyramid is super useful, but it was created in the time of monoliths. Yeah? And what we found was that this kind of bit of the pyramid is really now focused on individual services or functions. This bit of the pyramid we found really was focused on the system or the application at large. You can still do end-to-end sort of testing on a checkout service. You can still do exploratory testing, and the testing team I worked with did do that using like a Postman on the REST API. But really, that's the kind of split we found. Like now, the test pyramid is a fantastic model, but it's very much from the monolith times versus microservices. What we're kind of missing is this kind of joining bit. If we can get lots of confidence that our component, our microservice, or our function as a service is good to go, and we can get lots of confidence in the overall system using lightweight, kind of happy path tests, then we can kind of, I don't know, a few of you may have separated up the front end and the back end. You do lots of testing on the back end, lots of testing on the front end, and you do some very light integration testing to put them together. So you have kind of separation of concerns. You can do the same with a microservice or a serverless system if you get it sort of right. And I found contract tests quite useful as the kind of glue between lots of automation around each service and then some automation and some manual testing at the system at large. And I don't know if people have bumped into this, so the technologies I'll mention, but it does capture this kind of problem where you are pushing individually, but you break the contracts. Unintentionally, but you break the contracts between two services. Now, APIs are service contracts. Yeah, much like in Java interfaces, obviously Java interfaces, we have compile time safety. When you're building microservices, unless you're using like a language like Ballerina, as a new language come out, but in general, you don't have type safety when you're calling across boundaries. But the APIs are your types, are your service contracts. Have people bumped into consumer-driven contracts before? I see a few hands. Yeah. Unfortunately, with the time limits today, I'm not going to talk much about the technology, but I encourage you to have a look. I'll give you some guidelines in a minute as to when I think it's useful. But it basically flips the kind of traditional notion on its head in that the consumers of a provider dictate the change. The consumers say, I want this in my API. We codify that. And the producer then can run that codification in their pipeline to make sure they're meeting our consumer requirements. And if you have, say, 3 consumers here, the producer will only pass and build successfully when the code in the producer has met the contracts of all 3 consumers. It's switching the head of SOA. SOA was very much, I build a producer, I tell you what I'm going to give you. This is kind of flipping the head, and there is some benefits on doing this. Martin Fowler, has done some fantastic things. There is a bit of a joke that the Martin Fowler articles that if you cut into a system, the number of Martin Fowler patterns you can see in the system is the age of the system, much like a tree trunk when you cut through. And I see this quite a lot in contracts when I work on, but Martin's stuff is fantastic, and I've got so much value over the years and that article explaining about consumer-driven contracts is super useful. In terms of technology, 2 frameworks I've used quite a lot. I've used Pact on the left there, and I've used Spring Cloud Contract. Now, Pact is a multi-language. So I worked on one project, we had a Ruby monolith, and we were adding Java and Go microservices. And Pact supports many languages, but we could write contracts sort of at the seams of the Ruby monolith to run build tests in our Java microservices and vice versa, using Pact framework, because it uses JSON as a kind of like the interop in terms of the actual definition of the contract. Spring Cloud, as Ray said just before me, if you're a Spring shop, like Spring Boot, Spring Cloud is fantastic. If you're just Java, just Spring, the developer experience is fantastic with Spring Cloud Contract. But if you're multi-language, like many of us are these days, Pact is an alternative. And it's kind of like TDD for your architecture. You can write, basically, 2 ways you can do it. You can either write the contract in YAML or JSON, kind of like writing the Java interface and then coding an implementation. Or you can create mocks and stubs. Like basically, you write a test and you mock out in the code what you expect. You crank the handle, and that test will run and generate a contract from your test expectations you've mocked out. If any of you have used WireMock, you can actually use WireMock. Spring Cloud Contract does use WireMock behind the scenes, but it's a really nice way to test drive your architecture. Yeah. And Spring Cloud Contract, this is an example. I think we did this one in, it was just like a sort of YAML style format or JSON style format. I won't go through the workflow, unfortunately, this is part of a longer talk, but I wanted to leave it in there for the slide deck for you. This is kind of how I often do consumer-driven contract workflow, writing tests on the consumer. I then share, maybe I do a pull request on the producer's repo. I submit my new contract. They then run their test against that new contract, build the functionality, and then we can kind of coordinate the releases. Key thing that the consumer-driven contracts, it's not an excuse not to talk to the other team. It's often a cue for a conversation. If the producing team can't meet my contract, well, they come and have a chat to me. Well, oh, why have you done this? Why have you done that? I do see some teams trying to use as much technology as possible to avoid communication in the team. Yeah, and I get it. I'm a developer. As much as I'm standing here, I am an introvert at heart. Yeah, I get it. I don't always feel like talking, but unfortunately, this velocity and this stability thing means we have to work together more and more. And yeah, please do not use technology to kind of try and cut the collaboration. And if your leadership tells you the same thing, be very suspicious. The best software I've written has been in part of a very highly functioning team. Yeah, and we supported each other. So I think that's super valuable. So that's the workflow there. So you can have a look at this one offline. I've got some stuff in my GitHub. Got a few tutorials on my GitHub account as well. You can check it out. You can also do this. That's very much for RPC and for REST and JSON and so forth. You can also do the same with messaging, yeah, because like, the payload is effectively your API. If I've given this payload, and I'm looking for exact match, and then I change the API by removing exact match and in the payload, it may break someone who's consuming this message. And particularly with messages, it's often people I don't even know about, particularly in a big organization. I change an API, and like a month later, a batch process runs, and it just blows up. And that's my fault for changing the API. So you can, Pact supports AMQP. So if you're using Rabbit or ActiveMQ or something, you can use Pact to do verifications of contracts around message payloads. I'm sure many of you are using Kafka. The 2 Ks I bump into mostly these days are Kubernetes and Kafka. Everyone seems to be doing that. But Gwen from Confluent, who managed and steward Kafka, she's got a fantastic talk there. She did it at QCon. And Kafka have created this way of defining and verifying message payloads exchanged in Kafka using a format called Avro, but they've got a whole Maven plugin, and you can basically put it into your CI/CD. Her blog post is fantastic about how you build this into your pipeline. Again, it's a cue for a conversation, not an excuse not to collaborate, but it's a nice safety check that when you crank something out, you change your message payload in Kafka, you can hopefully verify, if everyone's conformed to this, you can verify that you're not going to break their functionality, the way they're consuming the payloads. So with contract verification, as an architect, one of the things I'm always conscious on is it's all a trade-off. Should I use Docker? Should I not? There's benefits, there's costs, and these things, yeah? And with contract verification, I think it's definitely worth asking if it's worth the cost to use things like Pack, to use things like Spring Cloud Contract. And for what I've determined, and this is totally my experience, kind of anecdotal, is that it's a trade-off around trust and communication and time. A couple of startups I worked on, we put in Pact, and we actually found it was more effort to maintain the pacts than it was just to have conversations and agree the APIs were going to change. We had some lightweight tests running in production, synthetic transactions that caught most of the other problems, but we were happy with the trade-off that if we did push something and it broke, we'd roll back, we'd fix it. Maintaining the packs was just taking too much of our time. I worked with some enterprises, and the packs saved us so many potential outages. Yeah, because just by the nature of the enterprise, you don't communicate with everyone quite so much. Trust tends to be a bit lower, particularly if you're outsourcing work, these kind of things. So just think about these things. This is very much my experience, my anecdotal experience. And a big thing I found is it does depend on whether you're choreographing, loosely kind of orchestrating services, or whether you're orchestrating. And I do see a bunch of people now, I'll skip over to Netflix Conductor, a bunch of people using this kind of stuff, where they are writing like lambdas and function as a service, and then they're orchestrating these little bits, little units of code using a DSL. Yeah, so that's just JSON. This is a Netflix open source tool. That's basically saying, if the result of this service gives 10 or something, we'll do something different here, and you can have like options, ifs, cases, that kind of thing. It's kind of like a programming language in JSON, pretty much. It's kind of also like BPM. Anyone's used BPM, business process modeling, BPEL, that kind of stuff. Very powerful for the right context. You can often generate flow diagrams. You can visualize your architecture. Super, super interesting. It's a hot space. There's lots of technologies popping out. So I've bumped into Camunda quite a bit from out of Germany at the moment. It's super, super interesting, but it's very much you're pushing your programming logic around from the actual code into these DSLs, into the JSON, into the YAML, that kind of stuff. And there, it's very much you're orchestrating stuff. So if you're choreographing, if you're using kind of classic microservices, and you're just doing RPC calls, you're exchanging messages, the interactions are quite loosely defined, I find contracts quite beneficial here, particularly if you're working in an enterprise, because you want to verify the behavior of the services working together. Yeah? You can often do end-to-end tests, but end-to-end tests verify often sort of interactions in a very narrow field. I spin up my whole service, whole system, I do end-to-end tests, but I'm testing I'm not testing the behavior of the component parts. I'm testing more the interaction of the system given that data and given that request. So I find contracts there can be very beneficial. And if people are familiar with TDD, different schools, this is very much sort of the London, as we call it, school of TDD, where you're verifying behavior. As Java developers, many of us are more familiar with the Chicago school using JUnit, where JUnit you do generally more assertions on, just like the value equals 35 or the value equals 42, that kind of stuff. If you're using things like mocking and service virtualization, that tends to be more London school because you're verifying interactions. Was this thing called? Was this thing called only once rather than verifying state? So I say, yeah, choreographing general microservices. If you're an enterprise, contract testing, very useful. Orchestration, I would say lint the DSL. So a lot of the tools like Amazon Lambda and Amazon Step Definitions give you a linting tool. So you can lint the JSON DSL. And then I actually just generally spin up a whole little mini environment with my Lambdas in. And I put some data in, I run the test, and I do a JUnit style, is this value 42? That kind of thing. Different kind of patterns. Right, so I'm getting a bit close-ish to time now, so I do want to move on a little bit. That's the testing thing. I learned a bunch of stuff in the testing. I made a bunch of mistakes there for sure. In terms of measuring what matters, so this is a key thing, and I'll look at it from the security point of view, particularly on this one, but I'll just briefly mention getting visibility for the business is super, super key. Putting micrometrics, fantastic new library from the Spring team, Pivotal team. I often use things like, I used to use like Dropwizard, Code metrics, or Spring Boot stuff, but I'm liking Micrometer. And then just basically dumping that into anything you like. You can Elk, Stack, Prometheus, take your pick. But creating simple dashboards to share business functionality helps a lot of conversations, in teams. So I'm definitely a fan of doing that kind of thing. But I want to focus more today on the stability angle, and testing like non-functional requirements. So I'm talking about things like architecture quality, bunch of books on the side I'm going to recommend. I'm sure many of you are familiar with SonarQube. It used to be called Sonar, for example. Performance testing, super, super important, and security testing. So I'm only going to cover architecture briefly now because of the time and security I want to touch on, because I think many companies I work with don't think about security testing in their pipelines. So I want to cover that briefly. Architectural visibility, you want to get a visibility of your architecture at multiple different levels. Adam Thornhill's work, Your Code is a Crime Scene, that definitely relates to some of my code sometimes, but it's a fantastic book about visualizing your code. What looks like New York City up there is actually a graph or a visualization of code complexity. So if buildings are tall, they tend to be complex. If they're wide, there's more code there. And the colors are based on the churn in Git. So a darker color building means more churn, more commits in Git. And what you can basically see is the kind of the high-rise, the blue buildings, they're kind of like the slums in your code. There's lots of code, they're highly complex, and the churn rate is really fast. I'm sure you can all think of bits of your code base where you go in, you fix something, and it's like whack-a-mole. You fix something here, something else breaks over here. You fix that, something else broke over here. You can visualize that. We did this on a project called Not on the High Street, which I've talked about before. And it's a nice tool. SonarQube gives you the more code, like cyclomatic complexity, gives you a breakdown at a finer grained level. You definitely benchmark your monolith when you start, if you're doing a migration, and look at your microservices. Check you're not doing the same thing. Are you making microservices just as complex, but smaller? Those things are important. And you also, as Ray hinted at in his great talk before, you want to get the runtime view of the system, using things like Zipkin or classic APM tools like App Dynamics, that kind of stuff, New Relic, all great stuff. Moving through relatively fastly, you can even unit test architecture. So I don't know if any of you bumped into Arch Unit. JDepend was an interesting framework, but it's not been maintained for a while now. But with Arch Unit, you can codify rules. You can say, this one is like DAOs must always reside in a DAO package. You can also codify, my clickers. There we go. You also codify things like classic ones, services should not access controllers. If you're doing the 3-tier ton of architecture, controllers talk to services, services talk to DAOs. You can codify this, and it uses reflection at runtime there, and it basically does pattern matching and so forth. It's an interesting way. It can, much like the contract testing, be quite verbose and a little bit constraining, but it's an interesting tool to have in your toolbox. Particularly if you're doing if you're trying to make a monolith more simple, you can do a pattern that's called the ratchet pattern, where you find like bad bits of code, and in your build you say, I've got 10 examples of this bad bit of code. You go and fix them, and every time you fix them, you reduce that number in the build, and if the number goes over the allowable number, it fails the build. So if someone tries to put in a package, a bad package or a bad example, the ratchet basically says, no, you're adding a new bit of code that we as a collective team we've thought is not good. So these kind of tools can allow you to do ratchets to kind of get rid of bad examples of code in monoliths, things like that. I want to just finally touch on security, because I know Simon did a fantastic talk earlier on. Hopefully many of you saw it. But you do want to think about security at all levels with modern architectures. I love FindSec bugs. Really nice tool. If people are familiar probably with Find Bugs, it's a static code scanner. It picks up like unused variables, all that kind of stuff. But this Find Sec Bugs is a plugin that looks specifically for security issues in Java. So I've done dumb stuff sometimes, and it's picked it up, and it's a real like Maven. A few lines in your Maven POM, you're good to go, kind of thing. It's real nice. Gives you a nice report as well of issues it's found. I regularly put it in my projects these days. Often when we're now deploying, say, things as Java containers, not only is my code super important, but I'm packaging the application with an OS. I've got Ubuntu, or I've got Alpine, that kind of thing in there. And you need to make sure that what you're putting in that Docker container does not have vulnerabilities too, does not have Heartbleed or all those kind of bad things. You want to minimize your kind of Docker attack surface for sure, but you also want to run a scanner. And Claire is an open source. It's created by CoreOS. Open source scanner that, kudos to Armin. I did this talk in London a while back, and Armin actually said to me, like, Claire itself is a pain to get running. Yeah, it's a great tool, but it's a pain to get running. Armin created a Docker container which scans other Docker containers. So you literally, you have to trust Armin's code, and you can build it from source as well, but you spin it up, and you point it at a container, and it will check against the national vulnerability database, and it will look for things like Heartbleed and so forth in your container. Fantastic bit of kit, yeah? And this is me just building it on Go, but just as a heads up, this is in November. I did this last year. If you can see there, I'm doing a Docker pull, just OpenJDK 8 JRE. This is the standard OpenJDK stuff, yeah? And I ran scanner, the Claire scanner. It's like a command line tool that calls out to the Docker container that Armin built. And I found, so this is, I literally Docker pull, I did the scan, and I found that many CVEs. People can't see it. That's like 100 critical vulnerabilities, or common vulnerabilities and exploits. And that was a bit bewildering. But as a developer, I would rather know about these security issues than not. It's a cue for a conversation with my leadership team, for example. I'm sure a few of you are familiar with Volkswagen, for example. An engineer went to jail for some of the Volkswagen stuff. I think we as engineers, at the moment, we're not regulated at all. Yeah, and we as professionals sometimes don't act the way other professionals do. If you're a lawyer or if you're a doctor, you have many more oaths and kind of practices. Whereas, if we're pushing this stuff into prod without knowing about any of these vulnerabilities, can we call ourselves professionals? It's really made me question, and it's caused a lot of stir in companies I've worked in. But my pitch is we at least need to know about these vulnerabilities. Yeah, if we're pushing Docker containers into production, we need to know about these things. Serverless is not immune to this stuff. I've had a few companies say, we're in serverless, Docker is not our responsibility. We push that onto Amazon. And Guy Pajami from SNCC, where Simon's from now as well, did a fantastic article that talked about this. And one of his key pitches was that since, yes, the OS is unreachable in kind of the serverless world, the attackers are now focusing on the code, focusing on more the application level vulnerabilities. Yeah. And again, the libraries we bring in to our code as Java developers, we are responsible for them. Open source is fantastic, but we've got to do our due diligence about what we bring into our applications. Yeah, and hopefully many of you bumped into OWASP, fantastic online consortium that focuses on security, maintains a list of common web vulnerabilities. I've used them for many years, but they've got some wicked tools. And the one I'm going to talk about very briefly now is the dependency check. That is like, 10 lines of Maven config, put it in your POM. Basically, it looks at all your dependencies, phones out to the National Vulnerability Database and says, I've got all these dependencies with these versions. Do they have any known CVEs, known exploits? And it was an old Spring Boot app. I think I had a 6-month-old Spring Boot app I was working on. I added this config to my POM, fired it up, and it came back with about 5 new vulnerabilities. Yeah? So I quickly, there was new versions out of these dependencies. I updated my versions, ran the tool again, no problems. But again, even if your code isn't changing, you need to be continually building and deploying to make sure that the world around you that's changing has kind of been captured in your pipeline as well. And just a nice report as well. So that's fine. One fun thing I would say is a lot of pushback I get is about we're agile. We do things the last responsible moment. And delaying non-functional or system stuff to the last responsible moment is not always valid. The kind of newsflash here is sometimes the last responsible moment with security is actually up front. People can't say to us, make it secure. We need to know, we as developers need to know what that means, make it secure. Yeah. Modern architectures don't make this easy. I've had a few projects where I've tried to retrofit security and so forth into them, and it was a nightmare with many different microservices in there. And it leads very much to this, yeah, you know, I can fix it, I can fix this right or I can fix this fast. Show me what fast looks like. And it's kind of the broken windows and, you know, all this kind of crazy stuff. So that's it. It's been a whirlwind tour. I wanted to get you thinking. I appreciate it's a lot of information. As a native speaker, I do talk a bit fast. I apologize. You know, the joke is you can pop onto YouTube and watch this at half speed, and you can probably understand what I'm saying. But the idea is to get you thinking, yeah, because I have made a bunch of mistakes which I'd like you not to make. So, you know, we are moving from complicated to complex systems. We need to design with these things in mind. I think architecture and the role I do is more about technical leadership, and we need to recognize that, act as professionals, and codify this stuff in. Because I think regulation, without getting too political, but I think regulation is coming our way, both in EU and both in US as well. And when the non-techie people try and regulate us techies, it's going to get pretty crazy for a while, I think. So we need to step up and look at some of these things. And I do strongly believe that we need to encode all these requirements. Many tools out there, but encode the requirements into a CD pipeline, both the functional stuff using, say, Serenity, and the non-functional stuff using all the tools I mentioned there. And this is a really powerful catalyst for driving change there. On that note, check out my GitHub. I've got some books coming out as well soon. One's already out, but all the stuff's free to download, the code and so forth. I'd love to hear your comments and things, but thank you for your time.